configuring rapid and multiple spanning tree protocol. So first things first, in this nugget we are going to be jumping out of GNS3 and into some real Cisco gear, some Cisco 3550 switches, which are great lab switches, by the way, simply because GNS3 in its current form only supports switching through EtherSwitch modules. And Cisco, by design, does not allow their EtherSwitch modules to support rapid or multiple spanning tree protocol because EtherSwitch modules are designed for small environments where people want an all-in-one kind of router switch device. So we've got some real gear here to do this. So let's start off with rapid spanning tree. And I'm going to start off with one of the most valuable spanning tree verification commands there is. It's show spanning tree. So know this command, no matter where you go, you can get a lay of the land just by typing in show spanning tree. So I'm sitting on CBT switch 1. So looking at this network diagram, I've got the typical diamond or pyramid triangle, what shape is that, of switches connected together, which is causing a loop in the network, and spanning tree is going to jump in and stop it. Now I type in show spanning tree on CBT switch 1, and by default, just about every Cisco switch when you pull it out of the box will be running normal 802.1d spanning tree protocol from the old days. I know that because I can look right here and it says spanning tree is enabled protocol IEEE. That, when you see that, immediately think, okay, old school, slow spanning tree, right? The other thing I can see just by seeing this list, actually, there's a lot. One is I can see this is running per VLAN spanning tree, because if I hit the spacebar, I look at VLAN 2, I look at VLAN 3, and each one of these VLANs has its own spanning tree instance. So this is, we'll call it Cisco proprietary, but it's really become kind of a de facto standard, that it's going to run one instance of spanning tree on a per VLAN basis. As a matter of fact, when I do a show VLAN, I see that I have 6 different VLANs that are active on here. So I know that there's going to be 6 instances of spanning tree running on this switch. Let's go back to the show spanning tree. Second thing I can tell from this command is that I'm actually standing on, not literally, the root switch, because I'm looking and it always breaks this command into 2 portions. One, it says, okay, the root of the spanning tree network, meaning the biggest, baddest switch, the one who has the best bridge ID and has won the election of BPDUs, is this one, because I see it says this bridge is the root. I can see that its priority is 32,769. I see its MAC address is 00. I mean, you can see it right there. It's saying hello once every 2 seconds. And then right below, it says, okay, and the bridge ID of this switch is exactly the same thing. You see 32,769, MAC address exactly the same as it was up here, because we're in a unique circumstance where we are sitting on the root bridge as of right now. Matter of fact, let me move my console cable over to CBT switch 2. Hit the enter key a couple times. Log in. And do a show spanning tree from this perspective, and look how the output changes. So sitting on this switch, I see, okay, show spanning tree. First off, notice the root ID doesn't say I am the root or this bridge is the root. It says a cost, meaning if I look at these 2 values, I see the root ID, which is saying the root of spanning tree is this guy, and I look at the bridge ID and I go, oh, whoa, 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 it's different. Essentially, this guy up here is not me. There are different switches, and it costs me 19, essentially, from switch 2's perspective here, to reach the root bridge. That's why it's sometimes valuable to memorize some of those common spanning tree costs, like a 100 megabit per second link equals a cost of 19, because I can see this output and be like, oh, okay, then I must be directly connected to the root bridge, whereas a switch further away, maybe, a cost of 38, a cost of, essentially 19 plus 19, assuming we've got 100 megs links everywhere. I'm sure nowadays would be more gigabit, 10 gigabit, those kind of connections tying them together. So I also see down here, another valuable thing, from this switch's perspective, fast Ethernet 0/1 is the root port. So I could label on a network diagram RP. This is the port that it uses to reach the root bridge, whereas when I was on the root bridge, anyone remember the port state? It was, oh, hang on, let me click in that window. It was designated right there, because its reward, essentially every single port on a root bridge, is always a designated port. You might remember that a designated port equals a port that is forwarding. Now, we also noticed when I was on switch 2, fast Ethernet 0/2 is the alternate or blocked port. So right there, it put that block on to make sure that we don't end up having a loop around the network in a broadcast storm, right? So that we can actually see a whole lot. That's just from doing the show spanning tree of what the spanning tree topology looks like. Now, when it comes time to convert to rapid spanning tree, it's one of the easiest configurations that you have. Go into global configuration mode, and this is on all your switches. So we'll go to global config and type in spanning tree mode R. Well, actually, let's just do a question mark. R rapid. I was trying to remember if it was R PVST or R rapid PVST. So again, Cisco doesn't run rapid spanning tree. It runs rapid per VLAN spanning tree. So if I go back now and do a show spanning tree, it's going to show rapid spanning tree protocol enabled. Instead of IEEE, it'll actually say rapid spanning tree, and I can see that each one of these VLANs have now converted over. Now, notice it took a second. If I hit the up arrow, I'll be able to see it on VLAN 1 as well. Notice that it actually recognized. It says, okay, this is a designated port. I'm in the learning state. Remember the spanning tree states, listening, learning, forwarding, or essentially blocking, listening, learning, forwarding, that it goes through. So it's learning right now the different MAC addresses, but it's already realized that the peer switch is running standard spanning tree. So essentially this guy is running rapid, but he backed down because he recognized that the peer switch isn't running rapid, so he's using the old timers. We're not really gaining any benefit as of right now. So I'm going to go to CBT switch 2, do the same command, spanning tree mode rapid per VLAN spanning tree. That's all there is, and boom, you improve your convergence time from 30 to 50 seconds down to about 2 seconds if there's a spanning tree failure in the network. So it's like, hello, if we support rapid per VLAN spanning tree on all our switches, there is no reason we should have any of them running the old school spanning tree, the IEEE 802.1d. So that's it. That's all there is to configuring rapid spanning tree. As long as all your switches support it, you'll get that fast convergence throughout the network. So now let's jump to multiple spanning tree. Now this one needs a little bit more of a description. With rapid per VLAN spanning tree, we get that per VLAN concept to where every single time I do another VLAN, it's going to spin up another instance of spanning tree so that we could have more root bridges. So you can see when I do this show spanning tree, it's going to do VLAN 2, VLAN 3, VLAN 4, etc. Throughout the list. And I'll say the benefit of that is I can say, okay, well, the root bridge for VLANs 1 and 2 may be this guy, or the root bridge for VLANs 3 and 4 maybe that guy. You see what I mean? So by doing that, we have 5 and 6 being this guy, I end up with different blocked VLANs. So for 1 and 2, I said block VLANs, I meant block links. This one is not used. For 3 and 4, this link is not used, right? Because it's going to say, okay, this is the best link, this is the best link for 3 and 4, and then this one gets blocked. And then for VLANs 5 and 6, this link gets blocked. So the beauty is we have essentially a load balancing kind of way for each set of VLANs, if you will. But the problem with that per VLAN spanning tree is each one of these VLANs is running its own independent instance of spanning tree. It's high overhead. So what multiple spanning tree does is, number one, convert you into a industry standard way of doing this. Rapid and normal per VLAN spanning tree protocol is a Cisco thing, as in other vendors don't have the ability to play that game. Now they can integrate it. It's kind of a quasi-industry standard way, because what Cisco did is actually steal some of the bits from the spanning tree bridge priority and use that for VLAN numbers. And I mean, we can get into the details, but I don't want to. Now they did that, but they did it in such a way to where I can run per VLAN spanning tree, and it's compatible with other switch vendors out there. But multiple spanning tree really gives you the true multi-vendor integration. So here's how they do it. With multiple spanning tree, I can say, you know what? I'm going to have VLANs 1 through 3 associated with this one as the root bridge. You create groups of VLANs, because, I mean, think about this. In your switch topologies, you're not going to have, okay, VLAN 1 goes that way. That's the root bridge. VLAN 2, well, you're that way. VLAN 4, you're going that way. You don't want that kind of granularity to where every single VLAN has a different root of spanning tree. You want just groups. You want to say, okay, you know what? 1 through 3, you guys will use this one. 4 through 6, and I'm just using our case, we'll use this one. Well, what multiple spanning tree does is run one instance of spanning tree for each group, rather than running one instance of spanning tree per VLAN, since they're all going to follow that same topology. Now, that's Really cool. And what multiple spanning tree does on top of it is maintain its backwards compatibility. Let's say this guy ends up not running spanning tree. Well, what it's going to do is essentially say, okay, the edge of our multiple spanning tree region. That's kind of how it relates to all the switches that are participating together in this multiple spanning tree world are defined in a region, but the edge of that is going to be switch 3. So essentially, as we communicate with switch 3, the switches are kind of like, he's the slow guy. We'll emulate what's called common spanning tree, which means essentially one of these switches will be the root bridge for common spanning tree. Best way I can describe it is I think back to I don't know if any of you, like me, came from the Microsoft world. That was 14 years ago. I was teaching Microsoft technology, and that was back in Windows 2000, Windows 2003. We had this concept of the primary domain controller and backup domain controller. Oh, come on. Who's coming with me? Who remembers that? Shed a tear for Windows 2000. And I know many of you probably are still running Windows 2003 in your environment because it was a great operating system. Well, as they moved from Windows 2003 to Windows 2008 server, Microsoft did away with this concept of primary and backup domain controllers, and they said, okay, everything is now just a domain controller. They kind of went with this multi-master model, but the problem is they had these old servers out there, Windows 2000 and 2003, that didn't understand this domain controller where everybody's equal. They're like, there's one master, there's one writable copy of the database. He's the primary, right? So what they came up with is this. Here's what creeps me out is I can still remember this. FSMO roles, flexible single master operations. 14 years ago I was teaching that kind of thing and I still remember it. I guess that's the beauty of teaching, right? You never forget it. So they had a FSMO role of a PDC emulator. And I don't know if this is still around. I mean, Windows Server 2012. It's funny because, here's what's funny is I saw Windows Server 2012 and I looked at it, I'm like, not much has changed. It's still Active Directory. You still have your users and groups and global groups and local groups. So don't hear me bagging on Microsoft folk, but that was so the reason I left Microsoft is I kind of reached the end. I'm like, I don't think there's much. Now, it's okay. Don't hear me come across as like, okay, I'm the master of it. But I reached a point where I was like, I'm not learning anything new. I mean, unless I'm willing to go into the development world and start programming in Visual Studio, and who wants to sacrifice their soul to that kind of horrific life? Unless I do that, I'm not going to really learn anything. That's why I jumped out of Microsoft and got into Cisco so many years ago. So anyway, this is probably still around to where they have a PDC emulator. You designate one server, we'll say it's that guy, to pretend to be the primary domain controller for all the old servers on your network. So bringing this all the way back around, that's kind of a long tie-in, right? That's kind of what happens with multiple spanning tree is one switch. Matter of fact, it's going to be the switch that is the root bridge of what's known as instance 0. Explain what that means in just a second. Will be the root bridge for common spanning tree. So when you reach the edge of the multiple spanning tree domain, this guy will, let's just say this guy ends up being it. He'll pretend to be the root bridge for the old school common spanning tree, the old configuration. So let's talk more about multiple spanning tree regions. So these switches cannot have just bizarre, wacky configurations. They essentially have to be part of the same club, right? What defines their club is known as the MST region. What defines the MST region? Well, when you configure multiple spanning tree, there are 3 criteria. 1, the name of the region. Now, this is free form. You can name it whatever you want. Region. So I could say CBT region or something like that, right? The second thing is something known as a revision number. Now, what is that? It's just a number that you make up. Usually, everybody uses 1 as a revision number, but they have to be the same. So, for instance, if I go out here and say, okay, well, this switch is revision number 2, and this switch is revision number 1, it's going to go shunk, and it's actually going to cut that multiple spanning tree domain in half, and it's going to say, okay, well, we aren't compatible, so we'll run common spanning tree between each other, because we're not in we're not communicating the same way. We're not in the same club, if you will. So we want to have the same name, the same revision number, and the same VLAN instance mapping. Essentially, what VLANs are assigned to the same group. Remember I was saying, VLANs 1 through 3, this guy might be the root bridge. VLANs 4 through 6, this guy might be the root bridge. Well, if I goof that up and I say, okay, well, on this switch I configured it actually as VLANs 1 through 2, and this switch, instance 1 was VLANs 1 through 3, and all this kind of stuff. It'll make sense when I show you this configuration. But they have to be identical or else they don't work. Welcome to your biggest troubleshooting with MST. Case sensitive on the name. VLAN mappings have to be the same. Notepad is your friend. So let's get into the configuration. Let's start off on switch 1. Now we're currently running normal, rapid spanning tree, just like we were a second ago. So I'm going to go into this switch, go into global configuration mode, and first off, enter, there's a little more to it than just flipping the switch, type in spanning tree MST configuration. And it'll actually take me into this little sub-configuration mode. And inside of here, I'm going to first off do my instance, or I shouldn't say instance, I'll say region name. So my multiple spanning tree region name will just be, let's call CBT nuggets. Right? So all the other switches that are going to be in the same region have to have that same name. I'll do revision number, and you can enter any number you want. I always put 1. That's just because I do. You could put 0, you could put 65,535. It's just a number. Just has to be the same between all of them. Some people even leave that off and just it defaults to 0. So, it's one less thing to worry about. I like typing it just so I can see it in the configuration. So revision 1, and then this is the big part. We're going to do our instance mappings. So I'm going to say instance, and you can see what is your instance ID. I'll say instance 1 will be VLAN 1 through 3. Seeing what I'm doing here? I'm going in, I'm defining the different groups of VLANs that will use a common spanning tree topology, right? One instance of spanning tree for those 3 VLANs. So instance number 2, you see where I'm going here, right? Instance 2 will be VLANs 4 through 6. So even though this switch 1 is not going to be the root bridge of those, it still needs to know about that instance because it will participate in this little communication with switch 2. So all the switches that are part of the same MST region will need to have those same configuration. Okay, so now, and by the way, this is where Notepad will be your friend. Let me bring up Notepad. Matter of fact, just so you don't have to watch me type it all in, let me just paste that same exact configuration into switch 2. All right, I'll come in here to switch 2, paste that in. Bam, we've got the same configuration. So the configuration is set, but we're not actually running multiple spanning tree until I do that same command. Spanning tree mode, and then we'll do MST, multiple spanning tree. Now, of course, I switched the console cable without doing that on switch 1. So let's jump over to switch 1, and we'll just do spanning tree mode MST. Good. So we've now flipped the switch on both of them. Let's come back here and do a show spanning tree. And there we go. We can see the protocol has flipped over to multiple spanning tree. Now, look at what's happening. Remember before with rapid spanning tree, it said VLAN 00001, VLAN 0002. So we see instead multiple spanning tree 0. That's instance 0. Hit the space bar. Space bar again. Multiple spanning tree 1, right? Multiple spanning tree 2. And notice this bridge is the root of all of them. So right now our configuration is almost done. We're running multiple spanning tree. They're all the group. But the problem is this guy is the ultimate master of rootness. He's the root for both groups of VLANs because we left it at default. Now, hang on one second. I know some of you are probably wondering. Now you defined instance 1 and instance 2. What's instance 0? Well, instance 0 actually is very special because number 1, I just mentioned it a moment ago, that is the instance that governs common spanning tree. Meaning, when we reach the edge of that region, whoever is the root of instance 0 will present himself or herself, depending on the kind of switch you have, as the root of common spanning tree. So these other switches that aren't participating in the multiple spanning tree region will say, oh, okay, you're the root, and we'll just use you as that, right? Second thing is any VLANs that you did not assign to an instance falls into instance 0, right? Check this out. I'll do a show spanning tree. Is it just configuration? No, it's I bet you it's show spanning tree MST configuration. Yeah, there we go. So when I do that, there we go, perfect. Picture paints 1,000 words, right? Instance 0, seven. Everybody's like, why are you still talking then? So there it is, all the VLANs, up to 4,094 VLANs that we can have. Instance 1, instance 2 are all right there. We are humming along. So what's the missing piece? Well, we haven't made switch 2 the root bridge of the instance 2, right? So how do you do that? Well, let me switch my console cable back over. I'm on switch 2. Let's just do, I'm going to do a quick show spanning tree. This switch, MST0, he sees the other guy, switch 1, essentially as the root bridge. Notice pretty much the same kind of behavior as before. It's got the root port on fast Ethernet 0/1. It found that was the best way to reach the root bridge. The alternate port, or the block port, ended up being fast Ethernet 0/2, right? So, also notice the cost change. What's up with 200,000? We went from 19 to 200,000. Why? Well, because the creators of multiple spanning tree, this is, by the way, the latest and greatest version of spanning tree, because it really is rapid spanning tree protocol that does the per VLAN-ness on an industry standard basis in a very, very, trying to undo. There we go. Scissors. Okay. It does the per VLAN spanning tree ness on an industry standard kind of way. So they said, well, why not? While we're revising the standard to do multiple spanning tree, let's adjust the cost, because you know what? 100 megabits per second isn't fast anymore. Like it was back when rapid spanning tree and normal spanning tree protocol were being developed. Now 100 gigabit per second is a reality and beyond. So they adjusted the cost with multiple spanning tree to handle those kind of scales. Good for them. Well done, guys. So multiple spanning tree, where were we? Okay, making switch 2 the primary of instance 2, thus being the root bridge for VLANs 4 through 6. I go into global config mode, spanning tree, very similar to what we did before. Spanning tree MST, but instead of typing in configuration, I'm going to actually type in the instance, kind of like we did with normal spanning tree, to where on this normal spanning tree I can go and type in spanning. Actually, I'm right here. I'll show it to you. If I was using normal or rapid spanning tree, I just type in spanning tree followed by VLAN number, because it's a per VLAN thing, and I type in a range of VLANs. Let's just say 1 through 3, and I would do a root primary. Right? That's how you do it on normal spanning tree, and that command takes effect for normal spanning tree. And let me show you, this will be such a great comparison. Watch this. So I'm going to do spanning tree MST. So instead of doing a VLAN number, I'm going to type in an instance number. So we'll say for instance 2, which based on the configuration that I did right there, is going to be VLANs 4 through 6. You guys following me? Yeah? So instance 2, I'm going to do, and you're going to see the commands are exactly the same, root primary. Boom, done. This guy is now the root bridge for VLAN 2. So the reason I said this is going to be so perfect, look at this. What's the difference between what I just did right here and what I did right here? Nothing. Well, okay, I know. You're like, well, that's VLANs 1 through 3, the others 4. No. I mean, conceptually, what's the difference? Nothing. This essentially sets the root bridge as the primary for VLANs 1 through 3, and this sets the root bridge for primary for VLANs 4 through 6. Big difference is with multiple spanning tree protocol, I'm only running one instance of spanning tree for that VLAN 4 through 6, whereas doing it this way runs 3 instances of spanning tree, of which this guy is going to be the root bridge of all of them. Right? So it's just more efficient, and it's an industry standard way of doing it. We can do multiple spanning tree outside of Cisco switches, so that's an advantage there. So hey, while we're here, why not? I can do spanning tree MST for instance 1. Let's make him the root secondary, right? So let's go back and see the result of that. Show, actually, probably the result of that is, hang on, I gotta go adjust switch 1, because by typing that in, it will probably become the primary, because I haven't set the primary as the primary, right? So I'm going to go, did you follow that? So I'm going to go to switch 1, do spanning tree for instance 1, root primary, and spanning tree for, did I say switch 1? I meant instance 1, is going to be for instance 2, root secondary, right? So let's just take the view from here. I'll do a show spanning tree. Ooh, remind me to tell you one more thing about spanning tree instance 0. So I can see this guy still is the root because I haven't adjusted. Just by default, he's got that 32,768. He feels good about himself. He is the root bridge. He just happens to have the lowest bridge ID. This guy, notice priority has dropped because I typed in that root primary to 24,000. This bridge is the root of MST1 as I would expect. And then I hit the spacebar and find out he is not the root bridge of MST2. Notice he has this priority, this CBT switch 1 has 28,647, and the root bridge has 24,578. Because who is that? If I grab my cable, but you already know this, right? I'm going to do a show spanning tree on this guy, scroll down to instance number 2, and see that this guy has reigned as king. He is now the root of VLANs 4 through 6. Nice. Awesome. So, I told you to remind me one more thing on MST0. One of the other beauties of the way that a multiple spanning tree works is instead of sending one BPDU per instance, because remember, BPDUs kind of identify the switch, select them. The people who created this figured out a way to use one set of BPDUs for all instances that are running. That's so awesome. Because otherwise, you see these BPDUs, they're sent once every 2 seconds to make sure the switches are online. And a lot of times in mission critical environments, you'll even tune that time down lower because you want a faster convergence, right? So BPDUs can become a pretty significant overhead if you have a whole bunch of VLANs in per VLAN spanning tree because you have to send one BPDU for each one. But with multiple spanning tree, instance 0 is essentially the one BPDU to rule them all, and it just includes inside of there. I'm trying to think. They call it a certain packet type. It's like an M tag or M something that essentially allows it inside of that BPDU to identify the different priorities for the different instances of multiple spanning tree that you're running. It's M records. I paused and looked it up. An M record is what they actually tag inside of those BPDUs to make sure that it can identify the different instance types within the BPDU rather than sending a unique BPDU for each instance. Good. Well, we have seen configuring rapid spanning tree protocol, one command, right? That's all there is to it. And multiple spanning tree, as well as a lot of the concepts surrounding multiple spanning tree. I hope this has been informative for you, and I'd like to thank you for viewing.